We're going to do antiderivatives day 2, so it's just more of the same. So a few common mistakes that students make with integrals is they don't write the dx at the end. You will get a penalty for that, a notation penalty, if you don't write the dx. Everything, if you started with an integral sign, you have to bookend it with the dx. And then when you're doing the indefinite integrals, which is all we've done so far, next class we'll talk about what definite integrals are, and you have to write that plus c at the end of the indefinite integrals. So just like with derivatives, you can't do this. You can't just have a product of two functions and integrate them individually and then multiply those integrals or those antiderivatives. There's no such thing as a product rule, and there's no such thing as a quotient rule. So this is one of the reasons why integrals are much harder than derivatives, because there are some functions who just don't have an antiderivative. This is an example of one. So the integral of sine of x over x, there is no solution to that because there is no function whose derivative is sine of x over x. So integrals, if you look in calculus or college level textbooks, you'll see pages and pages of integration rules that students have to know. So integrals are harder than derivatives. So sometimes you need to find, if you don't have a rule for it, you can use some techniques. So one of those techniques is to actually manipulate a function so that you can use a rule that you know. So this is one of the examples that we did last time I was here with you. This is number 8. And the technique there was to split up the fraction. So manipulating or simplifying your function before you integrate is a good strategy to use. With your notes in front of you, we're going to do number 9. Again, for number 9, the strategy would be to split up your fraction. So that's what I've done here. Now, this is really the integral of x over x to the 1/2, right? Plus 1 over x to the 1/2. You don't need to write that down, because this next step you can do without this. So when you're dividing the bases, what do you do with the exponents? You subtract them. So 1 minus 1/2 is 1/2. So this is really the integral of x to the 1/2 power. And then what can I do with this 1 over x to the 1/2 power? Bring the bad boy to the top. That's right. And that's going to be what? X to the negative 1/2 for that bad boy, as Will Priggy said. That's on the video now, Will. Notice I'm still writing my integral sign and my dx because I have not yet applied the power rule. All I've done is manipulated my original function. Now I'm going to apply the power rule so I can stop writing the integral sign and the dx. So I'm going to add 1 to the exponent, 3/2, and divide by 3/2. And for the next term, add 1 to the exponent, 1/2, divide by 1/2, start adding your plus c. So this then becomes 2/3 x to the 3/2 plus 2 x to the 1/2. You can call that square root of x if you want, plus c. Number 10, what do you think you're going to do there first before you integrate? Multiply out that bad boy. So I multiplied it out. Hopefully you got what I got. Now we're going to apply the power rule. So I can stop writing the integral sign. So when I have the 4x and I apply the power rule, it's the antiderivative of 4x. It's 2x squared. So great if you can do that in your head. Otherwise, remember, it's just going to be 4x squared divided by 2. What about the antiderivative of 3x squared? Yeah, it's x cubed, or if you want to do the whole thing, 3x cubed divided by 3, and the antiderivative of x to the 3rd. Yes, Bailey, x to the 4th divided by 4. And then now we're adding the plus c. If you simplify that, that's going to be 2x squared plus x cubed minus x to the 4th over 4, or 1/4 x to the 4th. Voila. Number 11 is pretty similar to number 10. All right, did you get that for number 11? So the last thing we're going to talk about is something that's called particular solution. When we have something like the integral of x dx, and we know that that's going to be 1/2 x squared plus c, this is what's known as the general solution. So this would represent, of course, if you think about the graph of 1/2 x squared plus c, 1/2 x squared is a parabola. It opens up. If the c value was 0, then it would pass through the origin here. These are different colors. Of course, I didn't print in color. If the c value is negative, it could be this parabola down here. And if that c value is positive, it could be one of these two parabolas. Okay. So sometimes you are asked to find the particular solution. And in order to find the particular solution, essentially what you're doing is you're going to be solving for c. But you would need to know more information about the original function or the antiderivative. So for example, if we were looking for this particular parabola, then they would tell you that the parabola passes through the point 2, 5. And then you can use that information to solve for c. So that's what's known as a particular solution, that process. So let's take a look at number 12. I'll walk you through it. We want to find a function such that the derivative is 2x plus 3 and that f of 1 equals negative 2. Of course, that means that on the original function, it passes through the point 1 comma negative 2. So since we're given the derivative, the integral of the derivative is going to be equal to what? Just give me a name. Don't tell me the value. Just give me a name for it. When you integrated the derivative of f, when you integrate f prime, you're going to get what? F. You're just going to get f, right? The integral of f, because essentially your integral sign and your derivative end up canceling each other. They undo each other, if you will. So in other words, f of x is going to be the integral of 2x plus 3 dx. So what's the antiderivative of 2x? X squared. Antiderivative of 3, 3x. We have to write this plus c over here. So now you're going to use this information, the fact that f of 1 equals negative 2, to solve for c. So I'll give you a minute. Substitute the 1 for the x, the negative 2 for the f of x, and solve for c. All right, hopefully you got that c is equal to negative 6. So now that you know what c is, you can go back and write your answer, because it says find the function f of x. So we know that f of x must be x squared plus 3x minus 6. All right, the next one, you're going to do the same thing, except you're going to have to do it twice, because I give you the second derivative, and you're going to have to go all the way back to find the original function. So try number 13 with your groups. So I'm working on doing the first half of the problem. So I'm integrating the second derivative to get the first derivative, and I solved for c, and I got that c is negative 1. So now I know that the first derivative function is actually 4x cubed minus 4x minus 1. So now I'm going to go over here and repeat the process for finding the original function, which would be the integral of the derivative function, the first derivative. Sometimes students get confused by, down here we said that c equals negative 1, and over here I have another c. This c is not necessarily equal to negative 1. It could be, it would be a coincidence. But these are two different c's. So sometimes to avoid that confusion, you could call this c sub 1, and then you could call this one c sub 2, if you'd like to make a distinction. Or maybe you call one of them c, and you call the other one d. You can call them both c, and just recognize that they're going to be different. So now we know that f of x is going to be x to the fourth minus 2x squared minus x plus 6. This problem is just to take you back to when we talked about particle motion. Remember that if you take the derivative of the position function, you're going to get the velocity function. And if you take the derivative of the velocity function, you're going to get the acceleration function. So when we did this before with derivatives, I was giving you position and you were finding velocity and acceleration. Now I can give you information about acceleration and velocity, and you can answer questions about position. So let's have a look at this problem. A rock is thrown directly upward with an initial velocity of 50 feet per second. We'll talk about that in a minute, but that is important. Initial velocity from an initial height of 10 feet. The velocity of this rock is modeled by this function. So you're given the velocity function here, where t is in seconds and v is measured in feet per second. Find the position function for part A, and then find the height and the velocity after 3 seconds. First of all, initial velocity. What do you think time is going to be when we're talking about the initial velocity? 0. So in other words, we can say that v of 0 will equal 50. What do you think we're going to do for initial height being 10? And we're calling our position function s. Sometimes you might call it x of t, but we're calling it s of t. So we're going to say s of 0 is equal to 10. So we want to find the position function. So we know that if I do the integral of the velocity function, dt, then I'm going to get the position function. So I'm going to give you some time to do the antiderivative of that velocity function to get the position function and solve for c. All right, let's go through this. So I did my antiderivative. I got negative 32 t squared over 2, which of course that's negative 16 t squared, and then plus 50t plus c. So we want to find the value of c. Well, we're going to use the initial height. So I can plug in the 10 for the s of t and the 0 for, and you can do this in your head. Whenever the t value is 0, it's pretty easy to do that in your head. What are you going to get for c? 10. So that means that your velocity function is actually negative 16t squared plus 50t plus 10. So that's the answer. Sorry, I don't know why I called it velocity. This should be position. So there's your answer for part A. Okay, part B, determine the height and the velocity of the rock after 3 seconds. So how am I going to find the height after 3 seconds? Into the position function that we just found, right? So you're going to do S of 3. I don't know what that is. So 16, and the units on that would just be feet. Then doing the velocity, you're given the velocity function. So negative 32 times 3 plus 15. What do you get for that? Negative 46 feet per second. And what does it mean when the velocity is negative and it's going down?